Afternoon, ladies and gentlemen. So today we're going to do MSM 132. So we're going to start with exercise 1. So we're going to do trigonometry today. So what is trigonometry? First, for you to understand or to answer trigonometry, first you have to understand what trigonometry is and what is involved in trigonometry. So the study of trigonometry, which is the study of triangle measurement. So tri means tri, it comes from those triangle. Trigonometry means the study of measurements. So this began a long time ago, more than 2000 years ago. That's when it began. So if I started at first as partially just solving problems, but later something was introduced. They introduced what we call now angle triangles. That's what is mostly based about trigonometry. So trigonometry is mostly based on right angles triangles. So first of all, we'll first start with circular measurements. So under circular measurements, we have something that you used to learn from high school. You must did about degree measurement. So degree measurements. So you knew that at a certain angle there are degrees. So now from degrees under trigonometry, we also have other ways of measuring angles. So angles are not just measured in degrees, they're also measured in what we call Latin measure. There's what we call Latin measure. There's also the evolution and many others. But in this segment, we will be talking about degrees and Latin measure. So let's first dive into Latin measure. Since into degrees, you know what degrees are. So let's go to Latin measure. So we have this circle here. So from this circle, we have this point here, center O. So O is the center of the circle. So so we have this part here, which has been divided. Which this is a sector. So from this sector, we have a radius which is R and two lead dies, which is OA and OB. We also have a, the angle here. So the angle here we call it theta. We also have the length from A to B or from B to A, which is denoted by the letter S. So this angle we call it this is the arc or arc length. So how do we find the angle which is in between here? So this center or subtended at the center here is by the circumference. We do it like this. So theta, which is angle theta, this one is equal to 2 pi r over r. So the r this r is this straight r here. Then 2 pi r, it's from the circle, this same entire circle here. It's given by the formula 2 pi r. So we'll cancel this r, we'll also cancel this r, which therefore theta is just equal to 2 pi. Now when you go back now to circular measure under degree, we said a complete circle for one complete revolution has how many degrees? 360 degrees. Then this complete circle in radians is given by 2 pi radians. So we said 2 pi radians is equal to 360 degrees. 2 pi radians is equal to 360 degrees. Now, as you can see here, you have a 2. This 2 can go into 2. 2 can also go into 360. So which means 1 pi is equal to what? 180, because 2 into 360 degrees is 180 degrees. So pi is given by 180 degrees. So under trigonometry, where you see pi, it's not the one you know at 22/7 back then. So under trigonometry, pi means 180 degrees. So now from this conversion you have made here, which is pi radians is equal to 180 degrees, we can establish two conversion factors. So the first conversion factor we have is to convert from radians to degrees. So when you're moving from this pi going to this 180 degrees. How do you do it? So you multiply the degrees the radians you've been given by 180 degrees over pi. So you multiply the radians you have been given by 180 degrees over pi. This same 180 degrees over pi. This same pi. Then number two, the second conversion factor we have is to convert from degrees to radians. How do we convert from degrees to radians? We multiply by, so everything will be using this same one. So here from degrees to radians we have pi over 180 degrees. So these are the two things you have to know. So let's dive into an example for you to fully understand what we are talking about. So we have example question 1. So question 1 says convert the following from degrees to radians. So from degrees to radians. So let's go to solutions first of all. So we have 60 degrees. So we have to convert 60 degrees from to radians. So how do we do it? We go by the second conversion factor. So the second conversion factor is to convert from degrees to radians. Same as the question, what's the question saying here? So you have been given number 1, you have been given 60 degrees. So here the condition is you have to multiply by what? Pi over 180 degrees for you to convert from degrees to radians. So you multiply the degree by pi over 180 degrees. So we are multiplying this 60 degrees by pi over 180 degrees. So 0 and 0 will cancel first of all. Even the degrees will cancel because that's the same things. So pi radians here. So you have 6 here, you have 18 here. So how many times can 6 go into 18? That's what you have to ask yourself. So 6 into 6 it's 1. 6 into 18, 3. So you have pi over 3 radians. So 60 degrees is equal to pi over 3 radians. Then you also have been given 270 degrees. So we have 270 degrees. So you also multiply it by pi rads over 180 degrees. So 0 and 0 first can cancel. So you now have to find what number can go into 18 and can also go into 27. So you have first, so we have 9. 9 can go into 18, 9 can also go into 27. So what's 9 into 18? So we have, okay, 9 first into 27. 9 into 27 it's 3. 9 into 18 it's 2. So you have 3 times pi over 2. So you have, so 270 degrees is equal to 3 pi over 2 radians. Then let's do our third one. Our third one, we have been given 45 degrees. So 45 degrees. So for 45 degrees, you also multiply it by pi radians over 180. So you first have to ask yourself, what number can go into 45 and can also go into 180? So you first go 9. 9 can go into 45. How many times does 9 go into 45? It's 5 times here. Then 9 into 180. So first of all, 9 into 18 is how many times? It's 2. So you have 2 here. So you have 5 times pi over 20. Then 5 can also go into what? Into 20. So 5 into 5 it's 1. 5 into 20 it's 4. So you have 45 degrees, which is equal to pi over 4 radians. You are done here. Then we go to our question 2. So our question 2 says convert the following from radians to degrees. So we'll go by the first condition. To convert from radians to degrees, multiply by 180 degrees over pi. So our question has been given as number 2, 1. We have 6 over 5 pi. So we are multiplying 6 over 5 pi by 180 degrees over pi. So as you can see, your pi and pi can do what? Can cancel. Then your 5 here, 6 over 5 and 180 degrees. So how many times can 5 go into 180? So 5 into 5, it's 1. 5 into 180. 5 into 18, it's 3. Remember? 3. 5 into 30, it's 6. So you have 36 here. So 6 times 36, 6 times 6, it's 36. So 6, remember? 3. 6 times 3, it's 18. 18 plus 3 is 21. So it's 216 degrees. Then you are done. Okay. 216 degrees. Then you go to our question 2, which is 2 pi over 3. So you're multiplying again by 180 degrees over pi. So that pi and pi can do what? Can cancel. So we have 3. 3 can go into itself, which is a 1. 3 can also go into 18. So 3 into 18, it's 6 here. So you have 60 here. So 2 times 60, it's 120 degrees. Then you also have our third one, which is 3 pi. So 3 pi multiplied by 180 degrees over pi. So that pi and pi will cancel. So 180 times 3. So 3 times 0, it's 0. 3 times 18, 8, it's 24. So you have a 4 here. 3 times 1, it's 3 plus 2, which is 5. So 540 degrees. That's how you convert from degrees to radians and radians to degrees. So these questions are mostly found in quizzes and tests. That's why you mostly find them, even in exams. So you should be very mindful of these questions. You have to know how to convert them. So as long as you just know these two conversion factors, then you are good to go.